Okay, cool guys. Let's get started. So this talk is really about deconstructing the Oracle stack. So it's the oracles that we use in Multi-Collateral Dai. So let's start off with kind of oracles v1. This is kind of where we started from, what we used in single collateral Dai, and we'll kind of analyze, what were the properties, why was it good, but also, what kind of problems did it have. One thing you kind of have to know about our oracles is that we have this concept of a feed. So what a feed is it's a price submitter, right? So in our system, we have 20 feeds. So essentially, 20 individuals or organizations, right, are pushing these prices, and the oracle price is the representation of the median of all of these prices that are submitted. And feeds are appointed by MKR governance. So this is the architecture we had for oracles v1. You'll kind of see the split between off-chain and on-chain, and that'll be very relevant later. So in v1, what we had is every feed, right, would grab the prices from a set of exchanges, and it would push that price to its own kind of price feed smart contract. So you could essentially think of it as like its own personal cash. And then it would send a transaction to this medianizer contract, which would then take the median of all of the feeds. And then that medianizer is essentially the oracle for the Dai stability system, as well as all kinds of third-party applications like Compound, DYDX, Dharma, Nuos, SET protocol, et cetera, et cetera. Now, this architecture is what we use for single collateral Dai, and it worked quite well. But one thing you'll immediately see that's a problem is that every single feed is sending an Ethereum transaction, which is not only is it expensive, but it also means that it makes the oracle price that's on chain less sensitive, right? Because it's waiting for all of these different feeds, right, to get a transaction through. We kind of talked about this, right? Lots and lots of redundant transactions. But the also other thing to note is the operations we were doing were very, very expensive. So what do I mean by that? Well, every time a feed would submit a new price, it would, right, tell the medianizer, okay, you need to find the new median of the entire data set. Well, to find the median, you need to sort all the prices first, right? And sorting is a very expensive operation, right? It's an n log n operation, so doing that on chain doesn't scale very well when you start adding more feeds, right? When you have 50 feeds or 100 feeds or even more than that. So those are pretty much the issues that we set out to solve with our new architecture, oracles v2. So oracles v2 is what we're currently using for multi-collateral Dai. So our goals when kind of building this architecture were really about solving this problem of scalability that we were being held back by oracles v1. Reducing kind of the costs, so the gas costs that we were paying, right? Making the oracles kind of more reliable and resilient, and kind of reducing the latency between a price changing, in the centralized world, like centralized exchanges, right? And that being reflected on chain. So one of the key pieces of kind of architecture that we integrated was this idea of a gossip network protocol. So the one that we're using right now is called a secure Scuttlebutt. And so it's a peer-to-peer gossip network. And so for those of you who don't really know what gossip networks are, a really good mental model is to kind of think of Twitter. So if you think of like you have a bunch of participants in a network, and you post something, right? You tweet. So I tweet the price of ETH is something. Well, on Twitter, everyone who's following you, right, can see that, and they'll retweet it, right, on their kind of feed. Right, so the same thing happens in a gossip network where essentially through this kind of retweeting of the people that you're connected to, right, you can have messages just propagate through the network, even between peers that are not kind of directly connected to each other. It also has a very similar architecture to a blockchain in that all of these messages are essentially hash linked, and so you cannot really get rid of a message or mutate a message because it would kind of break this, this hash link structure because the hash of the message would change. So here's kind of the overall architecture diagram for Oracle's V2. So notice that on the off-chain side, lots and lots of stuff is going on now. And on the on-chain side, right, we've kind of shrunken that a little bit. So now feeds, instead of pushing prices directly to the blockchain like they did before, right, they're instead just pushing a price to this peer-to-peer gossip network. So in this case, Scuttlebutt. And then we have, in the Maker ecosystem, we kind of have this concept of a keeper. And a keeper is any third party that will run some type of bot, you know, for profit. And so the idea here is that there are certain actors in the system who are incentivized to update the Oracle price, either directly or indirectly. And we can talk a little bit more about that later. But essentially what the relayers do is they're constantly scanning this off-chain network, this Scuttlebutt network, for new price messages. And if I were to take the median of all of these price messages, is that significantly different from what we currently see on chain? And so, right, if it is significantly different, what it does is it packages up all of these prices into a single transaction. So it essentially does the sorting off-chain, right? So it'll pass the signatures, right? So each feed signs this data to prove, right, I'm, you know, committing that this is the price, right? So you pass the signatures and you pass the timestamps and you pass the prices, but you pre-sort this all off-chain because off-chain it's very, very cheap to sort something. And then now you're just submitting one transaction to the medianizer contract, right? So essentially we've gone from n feeds, you know, submitting n transactions to n feeds just submit one transaction. And so that, you know, increases our scalability substantially. It reduces the costs we have enormously. It makes the Oracle price more sensitive, right? Because we have much lower costs, we can run a much, much tighter spread than we otherwise would. And everything's a lot better. Another unique thing about this architecture is that it's kind of blockchain agnostic, right? So notice that none of this really touches Ethereum, right, until the relayer does that one transaction to the medianizer. So if you have sidechains, like say you're working on like a scale sidechain or something like that, right? You know, you can just deploy a medianizer on there, and for the relayers, right, instead of just pointing them to the Ethereum mainnet, right, you just point them to the sidechain. Another thing is that not only is it blockchain agnostic, it's data agnostic, right? So in this case, for multi-collateral Dai, we're just using prices. But really, in Scuttlebutt, all messages are just JSON. So any kind of data that you can represent in JSON, you can really use as Oracle data, as long as you're able to kind of interpret that in your medianizer smart contract. Okay, so let's talk about kind of what are still the problems with this. When I think of kind of when I think of multi-collateral Dai, I kind of think of, okay, what are all the things that could possibly go wrong, right? So you just start to think of things through this risk of like lens, like, okay, well, what if the Scuttlebutt network, you know, fails? What if there's some kind of seg fault and the whole network goes down, right? What if the client that these feeds are running, what if there is some kind of bug in there and all of a sudden, all of the feeds go offline, right? The client that the relayers are running, similar thing, right? What if there's a bug in there and it's hard to find, and one day it just pops up, and all of a sudden, we don't have a live stream of Oracle data. So what we're working on right now is just kind of redundancy, just to make this as resilient as possible, right? Another thing that, right, for example, we have a tool that you're using to query the prices, right, from all the exchanges, right? Right now, that tool that we're using is called Setzer. What if there's a bug in that tool, right? What if it, returns the wrong price from one of the exchanges? This next version of Oracles that we're working on right now is going to try to basically counter all of those weaknesses. So essentially, the name of the game here is just find all the areas of risk and just de-risk all the things. So essentially, right, the strategy is redundancy combined with failover mechanisms create more resilient systems. So instead of just having one client, instead of just having, right, the one feed client or the one relayer client, right, have multiple clients, right? We've seen that, we've seen this actually in the Ethereum ecosystem, right? I don't know if you guys were around back then, but a few years back, there was a bug in the Geth code, right? And all of the Geth clients simultaneously crashed. But because the network had both parity and Geth nodes, essentially the parity nodes saved the Ethereum network from like seizing up. So we've seen this kind of client redundancy like actually in action in our ecosystem already. So we want to apply that same kind of pattern to the Oracle stack. Right? Another thing is, right, we talked earlier about, well, Scuttlebutt is this great transport layer, but what if, there is some kind of bug in that? What if there's some kind of error? What if, someone finds an attack vector into that network, right? Well, now we want to have redundant kind of transport layers, right? So there's a company called HashiCorp that makes a product called Surf. It's usually used for like DevOpsy type of stuff. So to kind of almost like a heartbeat kind of way to see if like a server is offline, or to monitor the latency in a server farm. But essentially, it's the same thing of just a distributed network of passing messages, right? Slack just recently came out with their own kind of message passing protocol called Nebula. Right, there is IPFS has libp2p, right, which is a little bit more lower level, but could be utilized to an extent as well. Another thing we're looking at is, right, the tool you use to query prices, right? So you want to have redundancy there as well. So instead of just Setzer, we're creating a new tool called Gopher. Another thing is, right, new price models. These oracles are used for multi-collateral Dai to an extent, right? But they're also used by all kinds of third parties who are using assets that may or may not be part of multi-collateral Dai. And sometimes the median is actually not the best way to model the price of something. What if you have 5 exchanges, but 90% of the volume is happening on, Binance, right? Then the Binance price, has a lot more relevance than, say, the Ether Delta price that has like, $50 worth of volume or something, right? So you can do like a volume-weighted average price approach. You can do a kind of time-weighted approach as well. I think there's one called like CCCCAG. So you can kind of use these modular kind of price models as well. So this is kind of what the architecture for Oracle's v3 looks like, right? So you have these multiple kind of clients now, right? So instead of just Setzer for querying, you have Gopher and Setzer, and we can release like a reference spec so the community could create even more, right? You have a bunch of feeds that are now using different clients, so not everyone is just using the default Omnia client. We're creating a new client in Go called Ghost, and we could release a reference spec for that as well, right, to incentivize the community to create more clients for even more redundancy. Right, we're using multiple transport layers, right? So if there's a problem with the Scuttlebutt layer, right, fall back onto Surf. If there's a problem with Surf, fall back onto Nebula. God forbid there's a problem with all three of them, right? You can even have a centralized server, right? That's just hosting all of this stuff. All the data is signed, so there's nothing that whoever's running the centralized server could do, right? And even if they take their server offline, the other three transport layers are prioritized anyway. So even a centralized server in this case is a really good fallback solution. Same thing for the relayers. So each of the Ghost and Omnia clients, their relayer functionality, that will be kind of more resilient as well due to the diversification. And on the on-chain side, everything basically stays the same, right? You still have the same model of, it's still the same messages being passed back and forth on all the transport layers, right? It's still the same relayers just submitting one transaction of sorted signed data. So the model on the blockchain has kind of reached this like much simpler form. And really all the innovation that we're going to be seeing in oracles, not just from us, but from people like Chainlink and people like UMA, and probably all kinds of other oracle groups that are out there. Really all that innovation is going to be happening off-chain. Okay, so let's talk about governance, because I think there's like a big kind of misconception around what is decentralized versus what is centralized in terms of oracles. And depending on what company you talk to, they will just market you and say, this is decentralized. And sometimes you believe them and sometimes you don't. So at Maker, what we do is we don't hold any of the keys to any of the oracle stuff. Essentially, that authority has been given over to MKR governance. So essentially, MKR governance gets to vote on who gets to become a feed. If a feed is acting, has bad uptime, or maybe they're posting bad prices, or maybe they attempt to participate in an attack, right? It is up to governance, right, to revoke that feed, right? Everything goes through MKR governance, is what I'm trying to say. So we're trying to kind of build out this governance ecosystem around oracles more. And so there's a bunch of different things that governance has voted on in the past relating to oracles. We passed the DeFi public feed proposal, and I'll get into that a little bit more in a second. The Oracle incentives restructuring proposal, the responsible Oracle migration proposal, and the Oracle team mandate proposal. And I don't expect you guys to immediately know what those are, but we're going to kind of go into those one by one. So when we talk about feeds, we really have to talk about two different types of actors, and they both have very different types of properties. So we have this concept of a dark feed, and so dark feeds are supposed to be kind of pseudonymous individuals and organizations that submit price data. So you're not supposed to know who they are. At least you're not supposed to know, right, they're based out of, this country, or what their name is, or, if they work for some company or whatever. And this is part of this hybrid strategy of, well, it is much harder to kind of coordinate between anonymous actors, right? So if you have a bunch of feeds, right, that are all anonymous, right, in order to launch an attack, you need to first identify who these individuals even are, right, which is very, very difficult. It's kind of what we call like the coordination problem. The downsides to dark feeds, though, is that you don't really have a guarantee of Sybil resistance, right? So you have, what Sybil means, right, is you don't really have proof of like unique identity, right? So for all we know, all the feeds could be the same person, right? So that's a risk. And another thing is on the user side, people don't want to trust an Oracle system that is just run by these anonymous, people. I think a big criticism that's been leveled at us sometimes is like, oh, it's got to be like the VCs or like the Maker insiders or like the founder or like whatever. So there's this other concept of a light feed. I think light feeds solve a lot of the problems of dark feeds, but they also have their own drawbacks. So light feeds are organizations, and so they have these public identities. They're tend to be kind of stakeholders in the ecosystem. So they have a kind of set incentive to be a good actor, right? Organizations also kind of have reputation, right? So say if you're say if you're like 0x in the space, and if you participate in an Oracle attack, like your reputation is now ruined in this community. And from the user side, right, users tend to trust systems more, right, that are that are kind of distributed in terms of entity, like other groups that they trust. And this is not unique to crypto. This kind of happens in, say, like the banking world as well, and the technology world as well, in terms of where companies don't really want to buy into systems that are just run by kind of one other company, right? Because now they're kind of dependent. So IBM is a great example. A lot of people don't want to just buy IBM systems and now be dependent on IBM for maintenance and service and all that, right? They would rather, use some kind of open protocol rather than a proprietary protocol, right? Because nobody owns it. It's the same kind of thing, right, with the oracles in terms of nobody wants to use the proprietary oracles that, and trust that one group, right? When you can say, well, I trust all of these other organizations in, DeFi and in the greater Ethereum space a little bit, but together, I trust them a lot. And so combining kind of dark feeds and light feeds, you can get this really cool like hybrid model, which is optimal because it kind of preserves the hardness properties of dark feeds, right? This coordination problem, they're really hard to locate and identify, and it's hard to coordinate to get an attack together. But it also benefits from the reputation of the light feeds, right, who are stakeholders in the ecosystem that are public facing. So we talked earlier that governance passed the DeFi light feed proposal, and so this was the first wave of organizations that were onboarded to run a feed. So DYDX, 0x, the Maker Foundation, SEP Protocol, and Gnosis. So they're all running a feed right now in Oracle's V2, which is supporting multi-collateral Dai. This is also just the first wave. We're kind of trying to talk with a lot of other partners, right, to get even more kind of buy-in from other stakeholders in the ecosystem. So if this is something you're interested in doing, and you guys have like a good reputation in the ecosystem, come find me. We'd love to talk to you. We'd love to get you onboarded. Would be really cool. Another thing we did was kind of realign the incentives of the oracles. So earlier I said, I'm trying to look at the multi-collateral Dai system through this kind of risk lens. Where is the risk? And one of the risks is, what if the Maker Foundation were just to disappear tomorrow? Like, would the system still work, right? Is it truly decentralized in that, like, it could keep going without, any kind of other coordinating entity? And so one of the things that we kind of saw on the Oracle side was like, from a technical perspective, they would still work, but the monetary incentives to keep them running are not there. And so how can we realign these incentives to make the Oracle stack more resilient, not just through technology, but through financial incentives as well? So what we said was, all right, well, currently the foundation is paying feeds some kind of sum of money, right? And that is to basically fund the servers and their bandwidth and all that, right? And it serves as some form of disincentive, right, to be a bad actor as well, right? Because you would get cut off from this income stream. But to truly make this decentralized, right, the fees essentially need to come from MKR token holders, right? So in multi-collateral Dai, we have this kind of buffer, which we call the surplus buffer, and all of the stability fees that are generated from outstanding Dai loans go into that buffer. So we created this proposal, right, that MKR token holders will use some of that surplus to pay the fees, right? So now the fees have an incentive, right, to keep running even if the foundation disappears tomorrow. So that's one side of the triangle that's solved. So now you kind of need to give an incentive to MKR token holders to kind of govern this system in a way that is not just entirely self-serving. So what I mean by that is the multi-collateral Dai system, right now it only has Ethereum as collateral and Brave token as collateral, right? But there are all kinds of projects, right, especially in DeFi, that need oracles for all kinds of other tokens. And we would love to have oracles for those as well, but why would MKR holders be paying fees to submit prices for assets that aren't utilized in the Maker system? So you need some form of incentivization for MKR token holders. So what we've done is we've essentially added like a whitelist to the Oracle smart contract. Excuse me. Essentially, in order to read the prices from the contract, you have to be on that whitelist, right? And so if you want to get on that whitelist, right, you have to pay MKR token holders some sum of Dai, be it monthly, weekly, or whatever, right? So now you kind of have this holy triangle of like incentives where data consumers, right, can just say, okay, well, we want to have an oracle for this, say for XRP, God forbid. And instead of going to the Maker Foundation, right, now they just go directly to MKR governance. They're like, hey, we want an XRP oracle. We'll pay you, I don't know, it was like $500 a year or whatever the hell it is, right? And then MKR token holders vote, and right, then they approve it, right, or they reject it. But if they approve it, right, then they tell the feeds, okay, feeds, you now need to start submitting prices for not just ETH and BAT, but you also need to submit prices now for XRP, right? And so now you kind of have this resiliency in terms of this decentralized system that doesn't actually depend on any centralized coordinating entity, from the foundation. So another thing that we've been dealing with is that Maker's oracles, like the oracles v1 that I showed at the beginning of the presentation, are like highly, highly used in the space, almost disturbingly so. And I kind of understand why, because I think we were like the first kind of mainnet oracles, and so everyone just kind of plugged into ours because that was just the easiest thing to do. But there's kind of a problem with this in terms of that we don't actually know how many people are actually using this thing, and what kind of chain reaction it could trigger of compounding effects if, for example, we just stop running the Oracle v1 stack. So even though MCD launched back in November and Oracle's v2 launched with it, we're actually still running Oracle's v1 in parallel. So we know of like tons of organizations that are still on v1 that have come up to us and told us, but there's probably dozens more that we have no idea about. So this was a proposal, right, that MKR governance passed that said we would keep v1 and v2 running in parallel for at least 6 months to give everyone time who's running on v1, right, time to migrate over to Oracle's v2. The other thing that we said was, look, like this whitelist thing, right, is a little bit controversial as well, right? People are not, who've been using this service for free. Their systems that they've built up, maybe they don't have any income, right, to get on the whitelist for V2. So another thing that we said is, okay, everyone gets free access to the whitelist for any oracles for 1 year. So this gives, like, we don't want to leave anyone like hang them out to dry, right? This gives everyone the opportunity to, okay, I have a year to transition to another Oracle stack if I want, or I have, a year to, figure out if V2 is something I like that I actually think is worth paying for. So this is just kind of another way of kind of like aligning the incentives, because we're not trying to like hurt the ecosystem. It's just there's like very real costs to running these things, especially as you expand the number of assets that we support in terms of what we provide prices for. And so this is kind of like a necessary evil that like we have to do. And so the best thing we can do is at least make like the transition for the ecosystem like as easy as possible. Okay, so that's kind of it for me. If you're interested in Maker or in Oracles, we have like a super active subreddit. We have a really active forum. If you're interested on the governance side of things, all of the Maker governance stuff really happens in the forums. So check out forum.makerdao.com. If you have a proposal that you think, would improve like Maker or improve Dai, right? You should submit it on the forum, right? Generate some discussion, and then it can actually become a governance proposal, right? That can be voted on. So even if you don't own any MKR and can't actually vote, you can still, be the driver of like change in this ecosystem. We also have follow us on Twitter. We have an active Telegram, and you can also, talk to me and Mariano and all these guys over here on Rocket Chat. Cool. Yeah, that's it for me. Thanks, guys.